Hi guys, and welcome to video 15 in the But How Do It Know companion video series. And let's start by recapping what we have done so far. So far we have our bus on top here, and a way to see what's on the bus using these LEDs, and a way to write data on the bus using these dip switches right here. We have this section right here that allows us to control our RAM. And finally, the last part right here, which is the ALU, including the TMP and the accumulator registers. So if we look at this diagram from page 91 from a chapter in the book that's called More of the Processor, we can see that we have quite a bit of what's required already down. So everything on the left, the ALU, TMP, and accumulators we have. The bus 1 circuit is built in our ALU. Then on the far right, we have the MAR and RAM, and that we took care of a while back. So there's really two things that are left. The big box in the middle called the control section, which we're going to start looking at a bit later. But for now, we're going to be adding the R0 and R1 registers to our setup. So the registers R1 through R3 are general purpose registers that are used by the computer to store information that it needs to access very quickly or in the near future. So far we don't have any registers on our board, and we are going to be installing R0 and R1. But before we do that, we need to expand our project board, because these registers are going to live on top here so that they can be conveniently connected to the bus, which is going to be prolonged here. So I'm going to go and expand our project board, and I'll be back. Okay, so I've gone and expanded our project board here. Once this is done, make sure that you connect the bus lines with the previous ones, and also the ground and power for each breadboard. It's important to do this now. If you forget, it may take a long time to realize, and it will definitely produce weird bugs in your circuit. So now we can move along and see what we're going to be doing with our R0 and R1 registers. So the first thing you can see here is a new Arduino device that I have placed in the middle of our project board. It's not really necessary to do this right now. I put it there just to get an idea of the sizing and the perspective, but it's not used at this point in the project. So if we move on top, we see that we have two SN74HC373 chips, and both are connected to the bus using the green wires that you can see here. So these chips can have different output lines than input lines, but in John's design uses a single bus for input and output. So we're going to tie the input and output signals together of the register using those little green wires that you can see that are sort of slanted there. So once that's done, we move on a bit below. We'll see that our chips are powered like before, except the 5 volts comes from below instead of above. So that's important because on top we do not have any power. Then the yellow wires that you can see are the set and enable signals for those registers, and they're going to be connected and brought down until we reach a chip that is there, the SN74HC00, so a regular NAND chip. And the reason that it's there is to build two NOT gates. So if you remember from video 6, we saw that the enable signal for those registers is actually active low. So that means that the chip is expecting a 1 value, meaning disable, and a 0 value, meaning enable. So in order to keep our control signals consistent and having 0 meaning off and 1 meaning on, we're going to have to invert those enable signals. So that's why this NAND chip is used here. So I could have used a NOT chip, HC04. I chose to use a NAND chip for two reasons. Firstly, to stick with the spirit of John's design, and secondly, since I'm only using two of the NAND gates, if ever I have another need further on for an OR or an AND or something else, I can use the second half of the chip that's currently not being used. And to finish off, we bring the signals down to our control signal area at the bottom, like we did for all of the other signals, and we use our pull-down resistors to make sure that they have proper zero value when we're not using them. So let's go ahead and connect this, and then we'll give it a try. Okay, so we have everything hooked up to our project board here. So as you can see, I didn't install the third Arduino yet. We'll wait until we actually need it to put it in. So we have both our registers, R0 and R1 here. Both are connected to the bus. And we have our set signals and our enable signals coming down here. The set signals are going straight to our pull-down resistors, and the enable signals are going through a NOT gate first to invert whatever signal we're going to send it. So the control signals are in this order: R0 enable, R1 enable, R0 set, R1 set. So let's power our circuit and try it out. So what I'm going to do is I'm going to set a specific bit pattern in each of the registers, and then we're going to call it back. Alright, so my first pattern, I'm going to set it to R0. Then make a different one. Like this, set it to R1. So now if we clear our bus, we should be able to recall both patterns using the enable signal down here. So for R0, so that's working. We got our first bit pattern back. And now for R1, good. So we can now see that both our registers can be written to and read from properly. So we're good to go with these two. So now we're going to move on to one of the most complicated parts of John's design, which is the clock. I'll see you soon.